set alarm for 12:35.
First, let me share my screen.
I set your alarm.
Yeah, your microphone's on, buddy.
Sorry about that.
Everybody, can you see my screen?
Yep.
Yeah, like once again, midterm exam 2 information.
All right.
So your exam will be on Wednesday, April 1st. And you have to log all class lectures starting from 14 through 22. I mean, today this is 22. You have to look numerical problems and homework 3 and 4. Now, today I will be discussing the solution for homework 3. And by tonight, you all will be submitting homework 4. And by tomorrow noon, again, I will make the solution available on eCoursera for homework 4. Also, I will let you know your grade for the homework 4 by tomorrow noon. So you will be fully fine. So if everybody, did you receive my email I sent last night informing of your grade for homework 3?
Yeah, I received it.
Yes.
Okay. Okay. So now I will be discussing the solution. And I already uploaded the solution for homework 3 in the homework tab. Did anybody notice that one?
Yeah, I saw it.
Yeah. So you need to look the homework tab and then homework set 3 right after that solution for homework set 3. Similarly, by tomorrow noon, I will be uploading the solution for homework set 4. So you can see all the solutions there. And then now I am going to discuss that one. Then once again, regarding the exam, as I mentioned you, I will make the exam script available at 11 o'clock. This means 30 minutes before the start of the exam, so that you can take a print of the paper, because you have to write on the given script. I will provide the NRB space, so that space will be fine. And then your exam will end around 12:30 p.m. And then I will allow you another 30 minutes to scan it and to upload it on a Dropbox. So hopefully today I will create a Dropbox, for example, midterm exam 2. So is everybody fine?
Yes.
Okay, good. Now let me open the homework set 3. Can you see the homework set 3?
Yes.
Yeah. So I believe we have this one. So these are the problems. And then now I am going to discuss. So, I mean, some of you have done properly, or I mean, not fully, but most of that. Especially the issue is with number 4, when you calculated the current. In most of the cases, you got the wrong value. So let me discuss. So everybody see, first of all, you see, here are the solutions for homework set 3. In the first slide, I am writing the correct solution. So because this file has already been uploaded, so you can see the correct answers there. The question 1, the question 2, in that way, question 3, question 4. You see that in most of the cases, you made wrong in the current expression for the question 4. So this will be the current expression. So I am showing you. And then for the last problem, so many of you also made mistake in the last problem. So okay, so now for the solution, okay. So from here, everybody see. So I'm making the solutions for the first problem. So as you see that you have to calculate the voltage right side. So first I have converted into Laplace domain. So there was a capacitor, it has been 2 over S. So first I am calculating the total impedance. I mean, you have used the voltage divider rule or the mesh analysis, those will be fine. You have done properly. But here I am showing by using the total impedance. So total impedance, you see this one ohm is in parallel 2 over S. And then finally, that combination is in series with 1 ohm. So that calculation I am making it here. So I got, this is the total impedance. And once I got the total impedance, then I am finding the total current IT VI over GT. So this is my expression. And then I am finding the current I naught, this time. Because you are asked to find out the voltage here. So if you can know the current here, and if you multiply it by 2 by S, then you are done. That I am trying to do. So therefore, here is my total current. And now I am applying the current divider rule to find the current through this branch. So I am applying the current divider rule here. You see, current divider rule. I naught, and then I am calculating. Finally, once I got the I naught, this one, and then I am finding V naught. I naught multiplied by 2 over S. So finally, I got this expression V naught over V equal to this. So is everybody fine?
Yeah, I'm good.
Yeah,
Everything's good so
I
far.
think most of you have done this on correctly, so you are fine. And then question number B was find out the impulse response H_t. So therefore this is Hs. So from there easily you can get. So these two 1 over S plus 4 e to the power minus 40 ut. So this is fine. And now for C was when Vi equal to ut. So ut means unit step function. This means its Laplace is 1 over S. So in the previous V naught equation, I am plugging in that 1 over S. So I got this one. And then also you can use the cover-up method, but here I am showing you that traditional partial fraction method. And by using that one, I got A value half and B value minus half. And I substituted those two values here, and then finally I got this one. So V naught T half. So everybody did this one properly. After that, when Vit equal to 8 cosine of 2t, and then again, this is it Laplace transform. Again, I am substituting this one into the V naught expression. So finally, again, I am applying here that partial fraction method, and then finally, I got those numbers. And finally, this is my result. I think most of you have done this properly. Those who have not done or kept incomplete, please have a look and you may practice at home. I think everybody is fine, right, for problem number 1.
Yeah, it's good.
Okay. Now see number 2. So in this case, again, the question is, what's the V naught S? So this is the Laplace equivalent circuit for that problem. So what I am doing here, first on the right side, these two are in parallel. 1 over S and 2, these are in parallel. So this is that parallel combination. And then I am adding plus S means this one. So first term, I am operating this portion. So for this portion, so this is the total impedance. And then this is my loop, the circuit. So 10 over S is the main current source. This is the total current that is flowing through that on. And after coming at this node, it is being divided into two parts. Something is going here and something is going towards this direction. So I am interested to calculate the current that is IS. That's why you see here calculation and applying the current divider rule. So therefore IS is the 10 over S total current multiplied by this impedance 2 over S and the denominator 2 over S plus the right side that I calculate. This means the whole combinations of these three parallel and series combination. This one and that gave me, just look the calculation. Okay, so that gave me this one, 20 into 1 plus 2s over this one. Now, if you see the circuit, because your goal is to find out V naught S, so you have to get this current, IC current. So once you calculate the IS current, then this current is again divided into two parts. Something is going through 2 ohm and something is going through this one. You need to know how much current is flowing through the 1 over S. So if you can know, if you multiply it by 1 over S, then that is your voltage. So I have IS and now I want to calculate IC. That I am doing. Again, another current divider rule. So everybody see this one? ICS, the total current ISS multiplied by 2 divided by 2 plus 1 over S. So I plugged in ISS from here and I put it here and then after simplifying, I am getting this one. Just see my calculation. So finally, I mean this one cancelled and finally I got 40, when this S and this S cancelled, I got 40 over 2 plus 6s plus s square plus 2s square. So remember, this is the IC value. Now see the next page. So the V naught is this one. You see the first line V naught is ICS multiplied by 1 over S. And then I put that up. So this is my expression. Now from here, what I did from the denominator, I took 2 common factor, like 2, then it will be 3s, then it will be half AC square, and 2. So therefore, 2, and then it became 20. So now this is my function. Now we have to apply the partial fraction because you need to inverse Laplace transformation. So therefore, after that, you see, I decompose this one in that way. S plus this into S square. So what I did, therefore let 20 over this is A over S plus B over this function plus CS plus D this function. So then you need to calculate A, B, C, D. So once I calculate, so this is my expression. A was 20 over S minus B was this, and this is the C and this is the D value. And then you see that how I am manipulating because I want to apply cos and then sine those functions from the Laplace transform and inverse Laplace transform function. And finally, after long calculation, it gave me this result. So V naught T is 20 T minus 19.595 e to the power minus 0.3395 UT minus 0.404 e to the power minus 0.08025 T. This is multiplied, multiplied by this function cosine of 1.714 T UT minus 3.9 e to the power minus 0.08025 T sine of 1.7 T UT. So this will be the correct expression. And then many of you have done this one also properly. All students could not do, but most of you have done this one properly. So once again, everybody make practice and see. So is everybody fine up to now?
Yeah, I'm good.
Okay. Now go 3. Okay. You see 3. So therefore, before that, let's have a look the homework 3. So everybody see the problem? For the RLC circuit shown in the following figure, find the complete response if V naught equal to 2 volt. So this initial value is given when the switch is closed. So see the circuit, and because the V naught is given, so we have to analyze the capacitor. So we have to see that how we can consist this one. So therefore, based on this information, if you see the solution, you see, because this was the series circuit, so I divided that capacitor into 2 parts. So this is 9 over S and this is on voltage, so it's 2 over S. So now you see this is the total V naught we have to take into account. So this is the input and 6 ohm, this is S. I assume that in this loop current flowing is IS. So you see, first line I have written down that equation. This is the voltage source 2S over S square plus 16 equal to ion S. And ion S is causing drop across 6 ohms, so 6, then S, and then 9 over S. And then you see, because this is plus minus, so this is plus 2 over S. Okay, so then see the next line, what I am doing. So what is ion S? From here, this expression, oh, first I am transferring 2 by S in the left side. So that's why this on 2S, S squared plus 16 minus 2 over S. So therefore this whole thing divide by this on. Again, this on like simplifying. Denominator is this and numerator is like 6S plus S squared plus 9. And I just simplified. After simplification, I got this one minus 32 over this function. And then see what I did. So therefore, V naught S, this is ion S, this expression multiplied by 9 by S plus 2 by S. So therefore, see the circuit, that I current multiplied by this one plus 2 by S. That is your total V naught. So that yeah. So now moving forward, I just plugged in that number. I put that ion S value, this thing here, multiplied by this 9 plus 2 by S. So now this is my expression, minus 288 over this one plus 2 over S. So this is fine. So for this portion, I am applying that partial fraction. A by S plus B by this plus C by this plus DS plus C. And then after calculation, I got A equal to minus 2, B is this, C is this, D is this, C is this. Many of you have got this properly, some of you got little bit deviated value. So I don't know why, but this should be the value that you should get. And then I am plugging in all those things in the above equation. And then I am adding plus 2 over S. So plus 2 over S and minus 2 over S is cancelled. Finally, this is my expression. Finally, this is the result after making inverse transformation. So everybody fine until now?
So,
Okay,
Yeah, it's all good.
great. Yeah. Now see the number 4. Most of you have made mistake. Number 4. Okay. So first of all, everybody see the homework set 3. Yes. Everybody look number 4. So this was the question for the parallel analysis circuit. The following figure, find V naught and active. So 2 questions. You have to find out voltage here and we have to find our current flowing through the 4-ohm inductor. And two initial conditions were given. V not equal to 5 volt and I not equal to -2 ampere. Now everybody see, because this is the parallel circuit, so when you will be applying the Laplace transformation, you decompose the inductor and capacitor such a way that it still makes the parallel circuit. Then it will be easier. You know that there are two types of decomposition. You can decompose capacitor by a series combination or by a parallel. Similarly, you can decompose inductor by a series combination and a parallel combination. So please apply the parallel combination. Then you will be fine. So now see that calculation. Everybody see my circuit. This is that source 10. I decompose inductor in that way so that it makes me parallel. So 4 is, and this is the current source, but in that direction. I naught over this. So I naught value is -2, so -2 over this. You see the capacitor combination, I use the parallel combination. So 80 over S because 1 over SC, and then the current source in this direction, CV naught. So V naught was 5, and then finally C value was 1 over 80, it makes me 1 over 60. So this is the circuit. Now for this circuit, I'm writing the equation kind of the current law. Current entering equal to current leaving. You see, this current is entering in the upper node. This current is entering, and in the reverse way, you can say this current is entering. So that's why I have written 4 over S. And you see, because here the direction was here -2 by S. So you may assume, okay, this is the direction, upward direction, so +2 over S. And then the last one, 1 over 60, equal to, I have assumed here the voltage is Vs at this node. So therefore, Vs over this 10, this current, plus Vs over 4S, this one, plus this one. Vs over this one, that's why is Vs over 80. And then from here, I want to calculate Vs. That is my goal. So see my calculation. This is Vs count factor from here. This is, and finally I am getting, this is my Vs expression. Vs equal to 5s plus 480, this one. Okay. And then okay. Everybody got this one fine. Although some of you got like 240 here or 250, I don't know how you get it. So you see from here, how I'm decomposing this one. So I made 5 into S plus 4 because in the denominator, this one becomes S plus 4 squared plus 2 squared. So 5S, 5 into S plus 4. Because there are 20 here, but it was 480. So therefore I made 460. So therefore this 460 plus 20, it makes me 480. So some of you have got like 240 here or 250 here. As I don't know. As other things are fine. So everybody is fine up to now?
Yeah, it's just a lot of calculating.
Yeah, right. Yeah. So everybody did this fine, although this thing is wrong. After that, you see, you all made messed up. So everybody see the circuit. Your next question is find out the IS. Look the circuit. You know the VS. This is VS. This is the common. So if you just divide VS by this number, then that will give you the IS in Laplace form. And then you just apply the inverse Laplace. Then you are fine. So Vs over 4s, that is your IS. So see my calculation. That part like we all made it. You see here my IS. IS is Vs. That Vs I got here. Vs over 4s. So therefore you see this one. And so this is my function. And you see how I decomposed it. I just divide by 4 the numerator and denominator, So it was 5, so it is 1.25 s plus 480 divided by 4, 120, and in the denominator it is s into this one. So I am applying the partial fraction. This one, and then see my calculation. I got this one, A6, B minus 6, C value minus 46.75. I just plugged in there. And then finally, I got this result. So most of you got the wrong result for the IT. This will be the correct result. Most of you, what you did not do these things. You did, once you get the BT, you said, okay, BT equal to LGI by DT, and then you calculated IT by the integration rule. You went the time domain. So you cannot go the time domain in that way because you remember that there are initial conditions. So if there are initial conditions and if you want to go time domain, then you have to go back to that RLC series and parallel circuit transient condition. Like it is overdamped, underdamped, critically damped. Then you will be getting. So because this is Laplace, so you have to apply the Laplace approach. Then you will be getting the correct result. That's why you got VT, this is fine. So you have the VS expression, for example, this line, you have the VS this one. To get the current, you just divide by the respective reactants. So like that I did. So IS is VS over 4S. So I'm fully going the Laplace method, and that I got this result. So almost everybody made mistake this one. So everybody understands?
I probably just need to work through it again.
Yeah. But do you understand my approach? What I
Yeah.
am doing? Yeah. So everybody made mistake this one, like you did, V equal to L di by dt, because you attempted the time domain. You know, this is the Laplace problem, so you have to go the Laplace, because Laplace automatically will include your initial condition. But the way you are attempting, you will get the result by applying that one, but you have to apply the transient formulas, like overdamped, underdamped, critically damped. Then you will be getting the correct result. That's why you ended up with the wrong result here. So please, everybody, make practice at home. Okay, and then moving forward. Okay, so this is the like number 5. So the question for number 5. So this was number 5 problem. You see the circuit was kind of a small number, 1 Henry, 1 Farad, 1 Farad, 1 Ohm. But there are 4 questions. V naught over Vs, this is V naught, this is Vs. V naught over Is, here is Is. Number 3, I naught over Is, and then I naught over Vs. 4 questions. So now see, so many of you have done this one properly, but some of you got like the wrong result. So in my case, you see what I did. You see the right side calculation. First, I am making the total impedance. So you see, last 2 branches, these 2 are in parallel. That I am doing here, right side. And then the series with S. So this is my series calculation. And then parallel with on over S. That I am doing parallel over on over S. Finally, I am adding 1. This is my series. So you see the right side, this whole calculation, that is my total impedance. So this is my total impedance. Okay, and then once I got the total impedance GT, I just wrote that on here. And then once I got total impedance, then I am calculating IS. VS over G total. So IS means this current, total current. VS over D total. So I got this one. And then I gave a new name on the current here. Once I get the total current, then I am applying the current divider rule. something is going this way and something is going that way. I want to find out this name. I have given the name IXS. So this means IXS is the total current. This means this one multiplied by this one divided by this plus the whole combination of this one. So you see this one, whole combination of this one. Right side I calculate 1 plus S square by this one. Okay, and then I simplify it, and after that, see the next. Okay, so this is my IXS. I just put in. So this is the simplified format. And then I am calculating I naught S. So again, I am applying the current divider rule. So this is the current divider rule. So after applying the current divider rule, I got that one. And then finally, I got that V naught S, I naught S multiplied by 1. So this is my expression. So then, first part I am done. First one was V naught over VSS. So you see V naught over VSS. Directly, this is the answer. So I just gave the check mark. And then number 2 was V naught over ISS. So that was my V naught S, and ISS I calculated. I plugged in. So this one cancel. This one cancel. So the result is 1 over this one. So I get the check mark here. So then number 3, I naught over ISS. I naught is calculated. ISS was there. So this cancel. So finally, this is the result. So I get the check mark. And the number 4, I naught over ISS. So these will be the correct result. But sometimes you kept a different form, but your calculation is wrong. Somehow you calculated missing the series parallel combination. So everybody understand?
Yeah, it looks good. It's just a lot of calculations. Easy to make
Yeah.
here or there with an S or yeah.
Yeah. You are right. You are right. So, but if you just make, that you have to little bit patient and just algebra, that the way I am showing you the calculation, although you have used different strategy, you have used nodal analysis, that is also fine. I mean, everything is fine, but somehow you made mistake in calculation. That's why you ended up wrong result. So this will be the correct result. You see, like I'm getting simply because I manipulated before and I simplified. So this is my simplified version. So easily I am getting. And I have my ISS before. This is my ISS. So easily I am able to calculate and I am getting those correct results. So therefore, everybody, I recommend you all to please look carefully and make practice. I already uploaded these things. You might expect 4 or 5 problems, probably 2 problems from Laplace and 2 or 3 problems from the filter circuit. So I think 4 or 5 of you have submitted the homework. I recommend you all please by midnight. I think last time is 11:30. You upload your homework for, and then by tomorrow morning or at the latest by tomorrow noon, I will be uploading the solution in the similar way, so you can see. But then simultaneously, I will let you know your grade for homework set for. Probably that will I will let you know. If you open the Dropbox, you can see your grade for the homework for. So, is there any questions?
I have a question about the test. Did you say that we need to print it out and then scan it back?
Right. Because you
I
see,
don't have a printer available to me at the moment, but I do have a scan app on my phone. So can I handwrite the test first, or do I need to come up with a printing situation for this?
actually, I'm like, the way you did the midterm exam one, I like you to write on the given exam script, the script that I will be uploading. That's why you need to take a print so that you will be writing your name and you will be answering on that one. So if I allow you 10-15 minutes more time, can you print going somewhere? Is it possible?
Yeah, I mean, I have a printer. It's just the cord on it's messed up. I can see about finding a cord for it between now and Wednesday.
Okay, like if you need a long time, then I can give another 10-15 minutes more.
Okay.
For example, I can make the exam script available at 10:45. So you all are getting like 45 minutes for printing. Is this fine?
Yeah, I mean, if I have to, I can run to the library and print it out there and then just do it up there.
Yeah. And then once you are done at the exam, for example, at 11:30, you will be done your exam. Then I am giving you another 30 minutes. That time you just scan and you make a single, everybody please make a single file. Don't submit many like pages. Like for example, there might be 5 or 6 pages for the question. You scan, but make a single file and that you upload that single file. I think 30 minutes will be fine, right? After the exam for scanning and uploading on the Dropbox.
Yeah, that should be fine.
Yeah. Yes, but I'm giving another 45 minutes for printing because printing might take time. And then just, because this is kind of home take exam. So just please be honest. Please maintain your integrity. So we will believe you that please work independently. Don't be seated like together, couple of, please everybody work independently from your home. So I fully believe that. Then it will be fine, kind of home take exam. So please don't discuss with your friends or anybody. Just think in that way, like you are giving exam in front of me in the classroom. I'm not able, just I will fully believe it, and that's all. Does anybody have any other questions, comment?
Nope.
Okay, so everybody please submit your homework by tonight. I think 11:30 p.m. is the deadline.
All right.
Yeah, and then immediately I will start looking those. I will make that, and then by tomorrow morning I will upload the solutions for homework work. So you will be looking eCourseware homework tab. So you see the homework for right after homework for you can see the solution for it. I mean the way I uploaded solution for homework. Similarly, I will be uploading the solution for homework work, so everybody can see. And then also I will let you know your. And then I recommend you everybody please try your best to do very good in the midterm exam too. You just understand those homework problems and then I uploaded the class lectures. If you just understand those things, then you will be fully fine. I believe everybody will be able to understand all those 4 or 5 questions. And everybody, please try your best to do very good in the exam. Okay, so with that, then I like to conclude here today. So just one thing. During the exam, I will be available. I mean, you can again log in to that Zoom conference because you might have any questions or confusion about the question paper. So that full time, I mean, from 11:30 to 12:30, that 1 hour I will be available to answer your question, or for example, you are not understanding any parameters in the circuit or something. Therefore, I like you all also, you be joining the Zoom meeting day after tomorrow. You will be mostly writing, but just you sign in on the Zoom so that you can participate with me. Everybody understand what I told you?
Yes.
Yeah, I think that is convenient for you. If you have any question, immediately you can ask. So I'll be fully available that class time, 11:30 to 12:30. But I will upload the, I will be uploading the exam on the eCourseware. I will create a new tab like exam script, like where you can see the class lecture homework. There I will create a new tab, exam, and there you can see the exam 2 is available. That you need to take a printout. And then after scanning, you have to upload to your Dropbox. That Dropbox I have not yet created. Hopefully today or by tomorrow, I will be creating. So you can see that Dropbox for uploading the exam. Okay, everybody. So have a good day, and please be ready for the exam. So see you on Wednesday.
See you on Wednesday.
Okay.
Sounds good. Thank you, Dr. Ali.
Okay.
Thank you.
I see you.